My dear friends, today we'll drive a formula for the parallel plate capacitor. Parallel plate capacitor, like this is a plate, one plate, and area of this plate, area means length into breadth, that is A. And plus Q charge is given to it, plus Q charge is given. And there is another plate in the parallel plate capacitor which is totally, insulated from plate 1. The plate 2 is insulated, there is no connection between 1 and 2. The induced effect will take place, and with the induced effect, minus Q charge will appear on the inner face of the plate 2. And the outer surface of the plate second is grounded. When minus Q will be induced in the inner side, positive will be induced on the outer side. But as it is grounded, the electron from the earth will neutralize all the positive charge. So now there is no positive charge on the outer side. It has gone to earth. Okay, it is now disappeared because of the second plate is at earth potential. Only induced charges towards the inner face of the plate second. Now this Q charge and area of the plate is A, and sigma becomes the surface charge density, charge upon area. Okay. Now in the region between 1 and 2, there will be a electric field E, and in magnitude E will be equals to sigma upon epsilon naught. You will ask that from where this expression is. You just watch my previous videos for the calculation of electric field between the two charged plates, positive and negative. You will find that expression there. Now substituting the value of sigma here, then E becomes equals to Q A upon epsilon naught. Okay. Then when there is an electric field is here, okay, and distance between the two plates, it is small d. There is a relation between electrical field and the potential. So electrical field is potential over the distance, or the potential becomes electrical field into distance. What is d? The distance between the two plates. Substituting the value of E here, then V becomes Q upon A epsilon naught into D. Okay, this is the value of potential. Right? Potential, capacitance and charge, they are related with a formula. Vc is equals to, let I symbol for charge, let I take it capital Q. Vc is equals to Q. This is a relation between Vc and Q. Now from here we find the capacitance, okay, or the capacity C of the parallel plate capacitor. Capacity C of the parallel plate capacitor is Q upon V. Now already know the value of the V. Substituting it here, D upon epsilon naught into A. So Q and Q goes, and the value of the capacitance becomes epsilon naught A by D. So this is the formula of the capacity of the parallel plate capacitor. Keep in mind, in our case, the insulating was the free space or the air, then it is epsilon naught. And if there is any other medium, when the space in between the two plates is filled with some dielectric medium, okay, of dielectric constant K, or you can say relative permittivity, it is one and the same thing, epsilon R. Dielectric constant K or the epsilon R relative permittivity. Then formula for the medium means dielectric medium between the two plates. Then the formula becomes epsilon R, epsilon naught, A by D. So if between the two plates there is a medium of dielectric constant K, you can put it here K also, or the relative permittivity epsilon R. So this is 1, this is 2. Okay. First of all, capacitance of parallel plate capacitor, if it is a free space, then the formula is, this formula tells capacity of the parallel plate capacitor directly proportional to area. If the area is small, the capacity will be small. If the area is large, like this, then there will be more capacity. Second, this is the distance d between the two plates. If the d becomes less, mean like they are the two plates, they are very close to each other. No connection but close. And d is less, then the value of C will be large. If there is a far distance, they are far away from each other, mean D is large, then the capacity becomes small. So capacity directly proportional to the area of each plate, and it is inversely proportional to the distance between the two plates, as well as capacity depends what type of insulating or the dielectric medium is filled between the two plates. Now we can also define dielectric constant or relative permittivity in terms of the capacity of the parallel plate capacitor. First of all, like these are the two plates, and there is free space, no dielectric medium. Dielectric medium is like, you can say it is a free space. Then formula is epsilon naught A by D. If you fill with some dielectric medium, then formula is this. So dividing, Cm by Cc. So epsilon naught A D cancels out, and what left? Epsilon R or K. So here we define what is the dielectric constant. Dielectric constant is the ratio of the capacitance of the parallel plate capacitor when some dielectric is filled, whose dielectric constant we are interested. First of all, we find the capacitance when the dielectric is filled. Okay, then we find the capacitance of the same capacitor when there is a free space. We divide the two. Whatever the value comes, that becomes the dielectric constant of that dielectric medium. Okay.